For fabrication, we start with a standard silicon wafer. As shown in step 2, one can add gold contacts for input or output with standard electrical systems, if desired. Also shown in the light gray is an aluminum oxide porous wafer. This wafer can be created by oxidizing aluminum and then etching away the remaining aluminum. It has holes on the microscale and is an inexpensive way to produce a fairly regular microscale structure. In step 3, we deposit 3 different layers. First, a p-doped layer of silicon, then an n-doped layer of silicon, which together make a photodiode, and next, a metal catalyst layer which will be used to grow carbon nanotubes. After deposition, the aluminum oxide layer is etched away, leaving only the diode and catalyst shown in step 4. In step 4, the material is placed in a CVD chamber and single-walled conductive carbon nanotubes are grown preferentially on top of the metal catalyst. In step 5, the material is removed from the CVD chamber and physically or acoustically agitated in order to separate the carbon nanotubes. A surfactant may also have to be used in order to decrease the amount of adhesion they have for each other. The goal of this step is to create conductive layers or channels between the various neurons made out of photodiodes. Once the carbon nanotubes have been spread out sufficiently, the material is brought back into a furnace and heated in order to fuse the carbon nanotubes to each other. In use, the freestanding inorganic neural network is placed in an electrically conductive solution, which also has non-conductive surfactants present. When the voltage level of a given photodiode or nanotube rises above a certain point, the surfactant preferentially adheres to this site, preventing electrical loss from the photodiode to the ground of the conductive solution. Thus, the physically absorbed surfactant serves as a long-term memory, where those layers or channels of carbon nanotube which have higher concentrations of surfactant adhered to them are able to communicate more effectively with each other. The amount of incident light can be varied or pulsed in order to set up different modes of operation in the neural network. Here is a brief listing of selected sources. Also, thanks to Wikipedia for their excellent image of the biological neuron.